To start our unit on linear functions, we must start with the concept of slope. Slope is basically a rate of change over the horizontal and vertical axis. So we have learned about this in Algebra 1, and this should be just a quick review of some stuff that you've learned in previous years in math. So if we look at slope, we have a nice picture here of the rise and the run, and so a lot of times slope is defined simply as the rise over the run. So it's the vertical change, which is the rise, to the horizontal change, which is to the run, and we write this in ratio form, or easily known as a fraction. So if we look, we have a nice little formula here for this, and so the rise is actually just the change between the two y values from the given points, any two given points on a line that has a slope. And then the run is the change in the x values. Now, you can see that we use subscripts of x1, y1, and x2, y2. This really doesn't matter which order we take these in, as long as we're consistently pulling from the same point in the same order. So this formula for the slope of a line is extremely important for you to understand, and of course you will definitely have questions given to you similar to example number 1, where you must find the actual slope of a line that passes through two given points. And so you can see in example number 1, we give you 2 points, and we just ask you to plug that into the slope formula. And then you see we have a negative 4/5 for example number 1. Now, if we had changed the order and we had come in here, and instead of simply starting with the second parts, we could have started with 5 minus 1, and then we could have done negative 3 minus 2, and this still would have given us 4 over negative 5, which would have been the same as the negative 4/5. So you can see that the order does not matter as long as we pull them from the same points. Now, sample problem number 1 has us finding the slope of a line that passes through negative 2, 0, and 1, 2. So what I'd like you to do is just pause the video, use example number 1 as your guide, and go ahead and work this problem. Okay, and so I'll just take one method, and I'll start with point 1 and point 2. That way I can keep things straight. So I'm going to start with my y's. My change in my y's goes on top, and then my change in my x's goes on bottom. Now this is very important that if you're subtracting a negative, that you are paying very close attention to parentheses and not getting those confused. That's going to leave me 2, and that's 1 plus 2. So my slope is going to be 2 over 3. Now, if you chose the other route, you may have gone with 0 minus 2, and then you would have had negative 2 minus 1, which would have given you negative 2 over negative 3, and then of course the negatives cancel out, leaving you 2/3. So slope would have equaled 2/3 here either way. Okay, and that's a good quick introduction to calculating slope when given 2 points. The next phase of discussing slope will be to be able to visually recognize whether the slope has a positive slope, a negative slope, whether it's 0 or possibly undefined. We can do this by looking at the slope visually. We can also look at the value of the slope to give us some indication of this. And so this concept box is very, very important just for your understanding of slope. Now, I will tell you this, from my experience with the ACT and standardized test, if you know these things and can quickly move through these types of identification parts, you can get a lot of questions done a lot quicker than having to actually calculate. And so this will help you eliminate possible wrong choices on the ACT. So this is a good little box to, I don't want to say memorize, but have a good working understanding. Now, let's just take a simple look here. If we're talking about positive slope, we're talking about an m value that's bigger than 0. And so if we read the graph from left to right, you can see that it is rising. And so we like to clarify positive slope as rising. On the opposite side of that, we said that a negative slope is falling. And of course, we're reading this from left to right, similar to a book. Now, horizontal and vertical lines are a little bit more challenging. And I will tell you this, that This is what most standardized testing professionals would consider a test separator. Most students don't learn this well enough, and it separates the scores between the students who have taken the time to learn it and the students who have not. And so if we look at horizontal line, a horizontal line has a slope of 0. I mean, it has no rate of change as you run across a level playing field, so to speak. So if we're running down the street, and there's no incline, there's no slope, it's just a slope of 0. Now the easy way that I like to remember this is I like to take the horizontal line and I like to make a Z, meaning 0 slope. And that's just kind of my visual way of reminding myself. Now, on the opposite side of this, by the way, let me just clarify this. On 0 slope, what's going to happen is you're going to actually have a 0 value for your y's over some x value, and if we remember that a 0 is in the numerator, it is simply equal to 0. Now on the flip side of that, we have a vertical line, and a vertical line is a little bit more challenging. And the little visual I give myself is the fact that I say that it has no slope. Now this is different than 0 slope. What no slope means is it basically is undefined. There is no horizontal change, and so there is no steepness. This would be like jumping off a cliff. There is no gradual downcline. So the way this looks mathematically is that you end up getting some number value for your changes in y's over 0. And if you recall, anything divided by 0 is technically undefined. And so a vertical line always has some undefined slope. So this is a very good concept summary. This is extremely important for you to know and can be very beneficial to you not only in Algebra 2 and for the linear functions unit, but this is tested quite often on standardized tests. So let's take a look at an example of how we could ask you to do this mathematically. It says, without graphing, tell whether the line rises, falls, is horizontal or vertical. So we would first have to find the slope of the individual lines. So understanding the slope formula is important. And then we would have to determine how that slope value fits into our concept summary. And so you can see in part A, we had a positive slope, and so that means the line is going to be rising. In part B, we had a number over 0, which means that this is undefined, which makes the line vertical. So let's go to sample problem number 2 here. In sample problem number 2, we ask you to do the same thing. So using the example above as your guide, go ahead and pause the video and work the 2 parts of the sample. Okay, for part A, first things first, we need to find the slope of the line. So I'm going to say 3 minus 3, and then negative 4 minus a 4. So that's going to give me 0 over negative 8. And of course, that's going to give me a slope of 0. And remember, if we have a slope of 0, we have a horizontal line. And of course, visually, that looks like that. For part B, to find the slope, I'm going to say I have 2 minus 0, and then negative 2 minus 3, which is going to give me 2 over negative 5. Now, the fact that we have a slope of negative 2/5. The 2/5 right now is unimportant. We'll get to that at a later point in time, but what we're more concerned about is the fact that it's a negative sloping value. And so if it's negative, it's less than 0, so that means it falls from left to right. So it would have a general shape that looked like that. We can also talk about the steepness, if you will, of slope. And then we have this little grid here that kind of shows us whether it's positive or negative, just how the slope changes the steepness of a given line. And so I'll just use the positive sloping ones. So you can see here this main line here, and we recognize that this is actually f of x equals x. So that's our parent function for a line as we go through there. And you can see that as the slope increases, this actually tends to get a little steeper, and of course as it decreases, it would get what we would consider a little flatter. Now we'll talk a little bit more detail about compression and stretching or dilations as we go through this unit, but that is in essence what's taking place there. So take a little closer look at this paragraph and this these sets of graphs, and so you can get a better visual idea of steepness of slope. Okay, that wraps up our visual about rising and falling in horizontal and vertical.